Hello, good morning, everyone. Is it audible? Hello. Today I'm going to explain the logistic regression as well as the some process of that. Very thankful to you that uploading some of the useful content. Yes, yes, I will go for that. Email, I will check, Rahul, definitely if I'm getting that mail. I haven't checked. Right. I think some of the content that I have uploaded previously, and suppose some points are remaining, no. So that is also I'm going to upload, not an issue, right? So I'm just thinking about the part to be discussed, logistic regression, right? And in the last, some of the points that we have discussed about imbalancing, as well as even we have discussed about the cross validation techniques. Techniques we haven't discussed, but cross validation, where we get that problem that we have discussed, right? So once we cover up the logistic regression, this mathematical institution, then we go for the other content as well. Even I will tell you the cross validation techniques as well. Okay, and you know. Uh, it's not necessary to go with the all the algorithms, means means after the logistic regression and all. And first we will cover up the surrounding background, means surrounding areas, that what really affects on the algorithms implementation, because we know yesterday's point that if suppose algorithm step by step, means start to end the process that we know, then any algorithm you can put into the that particular stage, you can solve the any problems. But the point is that what are the factors that affect while we are going to implement algorithms? Okay, suppose we have a data set with the null value. What value do we fail that before going to into ML with zero? Null value. See, this is an data analytical, data analysis part, right? The first thing, if I'm discussing about null values, there we have two types of problem statement. If suppose that column behavior is an categorical, means categorical or continuous, right? If suppose if I'm thinking about categorical, then you have to choose best one, maximum numbers of which category it is, and you have to check other factors as well. Means that column is depends on which other column, which are the other columns that relate with that. Second, if suppose continuous, then you can choose the mean and median mode, and these are the things. But if suppose if you pass zero, then next time you don't know. Suppose amount column is there, and every sorry, salary column is there, and every column, every row has an 3,000, 5,000, 6,000, 10,000, or something, means biggest value. And if you are passing zero, definitely the way null value gives us a problem, similar kind of that zero also gives us a problem. Are you getting my point out? Means you can solve, you will get a solution of that passing a zero, but the definitely that zero also we are getting the problem. So that time we always think about that data is in categorical or what, data is in continuous or what type of data we are getting. Means you just find out that those values side columns. If suppose, how do we overcome with that? That's why no, you have to check about the categorical values first. If suppose that is continuous, like house price, or suppose the way salary column is there, you have to check about the salary column as well. Most of the people they think about we can calculate the mean and, so what about if suppose if you calculate the mean and suppose they have passed into that particular null value position, what is the major factor? Calculating a mean is the only assumptions. It's a chance. It's the option. We cannot say this is a solution, complete solution. And any null value problem solution is not a final solution. You have to check with the average. You have to check with the maximum numbers, the value we are already we have. These are the points we have to check. So we don't put the column in a ML train, slice that column. See, if suppose there is an low number of counts are there, means null value. Suppose thousands of observations are there, and suddenly you are having near about 10 to 15. That's okay. You can pass the any number of, like on the basis of your column behavior, you can pass a mean, median, mode, or you can pass the maximum number of count that category we have, or there we you can pass a 0 or 1. That's the one thing. The second thing is that if you slice down, definitely your prediction will be affect. Definitely affects. Why? Because if suppose that column is an most important for that particular prediction, then how can you remove or how can you slice down that column? Means how can you remove that column? Because that behavior is and depends on that, right? Uh, See, guys, everyone, I'm just discussing about with the Rahul, but you can check that the way he's asking the questions. Please go through that, because if you are reading the chats, then it's good, right? Please, changes over time. Yeah, sorry, changes every time. Result changes every time. We are run kernel ML every time random data goes into the train and test, that changes the prediction. Obviously, that's the factor. No, that's the factor. Actually, what happens? How can you decide that suppose you don't want to change the output? How can you decide? Single random state behavior. If suppose you do know 10 to 11 random state is equals to 10, and if you changes with the 11, then definitely your accuracy changes, random your training set changes, testing set changes. You cannot say that these are the all the constant values. Is it correct? No. And if suppose you change the test size, then also changes. If you pass the whole data set to the training, then also your all the values changes. So maybe you got the, yeah, that's the fall clear. Yes, that's good. That's good. Actually, you got the point. Okay. Hope the points you got the majorly. Okay. Let's go for logistic regression. We are going to work on it. Yes, yes. Null values. Actually, there is an stages, no, the way we have got the data analysis part. But while doing the algorithm concept, we haven't done any kind of null value analysis and all, because um, what's the type means what's the time that we have to go for the machine learning algorithm when you are thinking about that our data analysis part is covered, our data isn't strong now, then we can go for the then we can go for the prediction without any analytical process or without any data pre-processing, we cannot go for the machine learning process. So we have to check, we have to take the data set, like first we have to go for the pre-processing, then go for the prediction. So I have to find out this kind of data set and then we'll go for prediction. Okay. So let's go for the logistic regression. See, the first thing that logistic regression, what is the exactly logistic regression? Right. So logistic regression used to calculate the predict probability of binary yes or no event occur. Means whenever the event occurs, whether it's true or false, that time we have. Even we have discussed about some points of, you know, uh, some points, some implementation also we have done with coding. Okay, but the only mathematical concept that we have to discuss now. Okay, any COVID-19 that COVID that person is in COVID-19 infected or not, or insurance policies also means we have to give the insurance or not, or true or false concept, probabilistic concept that we have to discuss with uh, logistic regression. Okay, so this is formula 1 divided by 1 plus e raised to, that is an z. Z is nothing but your observational values, right? So I haven't passed here z. You can give the any name of that this value. So this formula where we have seen, guys, this formula where we have seen, any idea about it? Any idea about the discussional points that we have assigned? We have seen no this kind example previously. B naught plus B1 into X. What is that example? It's a linear regression, is it? So yeah, beta is there actually, but I say that's B. So I'll tell you, because in this PPT, I'm just passing the some linear regression problems as well. Slope. Slope example means linear regression example, no? Is it correct? So now I'm going to explain the points to be assigned into the related logistic regression. Say, before we going to enter into logistic, I just want to tell you binary classification is there, multi-classification is there, regression and clustering. Is it correct? Binary, multi-classification, regression and clustering. You just see the binary classification that comes under the supervised learning technique. Multi-classification also comes into the supervised learning technique. Regression comes supervised learning technique. Clustering comes unsupervised learning technique. Is it correct, guys? This is correct. Means now whatever the things that we are doing here, the binary classification, multi-classification concept we are going to implement in classification problems. So there is an binary classification means we know, multi-classification is multi-categorical data, and regression is in continuous infinite numbers of data. Then clustering is there. So that comes into the unsupervised. So same concept now I'm going to explain, means binary classification. See here. This is your linear regression left side, and right side you are having the logistic regression. Is it visible to you clearly? Yes. Can we go forward? See here. See here. The independent variable and dependent variable we know that x-axis and y-axis we know. But linear regression, what is the difference that we have? Linear regression has a continuous data, right? Continuous data. So you can say the 0.1, 0.2, 0.3, 4, 3, 5, 6, 7, 8, 9, 10. It's kind of salary, it's kind of house price prediction, it's kind of temperature values, humidity values, speed values, means wind speed values. It's kind of continuous. Even we have seen the content of, even we have seen content of linear regression module as well. But if I'm thinking about logistic regression, there we have the 0 and 1 values, means it's completely based on the probability. In the logistic regression, there we have the example of sigmoid function. When we go for the artificial neural network, no, you will get to know that there is two concepts, that threshold and second one is in sigmoid. So what is, so that's the p-value. Yeah, actually, see, actually the way we are implementing, no, Rahul, here means prediction value that you are doing, no, here, that is completely based on the it's like a sigmoid concept. Sigmoid concept, see here the S curve is there, we have, I think it's in front of you that we are having this concept. Just a minute, I will give you the concept. The predicted y lives and within a 0 and 1 range. Okay, sigmoid is works on the basis of the values should be above the zero point 0.5, below the zero point 0.5. If you are getting the above 0.5 value, then it should be a 1, and below the zero point 0.5 value, it should be a 0. It's kind of probability you are getting this. So if I go for the simple linear regression, you know the observation value. So y is equals to b naught plus b1 and x observational values, right? And b1 is nothing but your slope, and the intercept is equals to means nothing but your b0, right? And this is the factor that we have, means how much impactful of linear regression you can get it easily. So when I go for the simple linear regression, some little recap about it. See, B1 is nothing but your slope. So slope calculation purpose, we have the formula, right? Even we have checked the calculation, basic calculation about slope as well, right? And then we enter into where we enter into the intercept. Means slope calculation we have done, intercept we have done. Then we come up with the solution, means b naught plus b1 into x. X is nothing but your observational values. Then we have calculated the estimated error, right? I think this point we haven't done. This point we haven't assigned there, but don't worry about. We'll go for that. Here, the multiple linear regression also we have implemented with the simple linear regression point, y is equals to and y is equals to multiple linear regression, means b naught plus b1 into observational values. The way we have covered the linear regression point, see that formula y is equals to b naught plus b1 into x1. So same observational values we have to pass into where logistic regression. Only the changes that we have done into logistic regression, that is an by probability we are assigning. Your observational values always lies between the point above the 0.5 and below the 0.5, means prediction values. So whenever you go for the prediction purpose, just see the diagram. Whenever you plot something, you will get a value in between the 0.5, means in between 0 to 0.5 and 0.5 to 1. So what is the example we will plot? Means if you think about the sigmoid concept or logistic concept, these are the same, not an issue. But logistic directly gives the output in the form of 0 and 1. And sigmoid gives the you in the format of above point. If suppose if you are getting a 0.6, check I just mentioned there hypothesis, as well as you will get in that direction as well. So 0.5 direction in that 1 to 0. If you think about this one, 0.5 to 1 and 0 to 0.5, right? And if you are plotting the values, you know that credit card fraud detection, if you are passing into that, definitely you will not get in the values like 0.2, 0.31%, because that is a completely probabilistic column. So values, those are the prediction values we have that goes into the 0th point, and those values we have into the 1, you will get into the 1's line. Then logistic regression tells you whenever you pass the values, you will get in the values form of 0 and 1 only, right? So have an insurance or not? One is nothing but yes, he have insurance, means it's a what means we give the permission to the person that yes, you can go for the insurance or you will not go for the insurance. So now just check out. I just mentioned here sigmoid or logistic. Logistic is nothing but your logistic function. Okay. So directly comes into the form of 1, you'll get in that logistic function directly. But sigmoid tells you about 0.5, that comes into the probabilistic logistic regression. Now the discussional point is that how the work is going on, means how the formula is, how formula is we are going to implement. Just see how insurance age. So which age of person can allow for insurance? Suppose 30, 40, 50, 60, 70 age we have assigned. And here we have the insurance, means it is allowed or not, means person can get a logistic regression or not, means insurance or not. Now, I just want to go for here, just see what happened. See the one thing here. Wait, I'll just show you one. Hmm. This is your zeroth value, because the way you are getting the values here, this is your observational value. So plus sign is an observational values, and this is also observational values. If you put your prediction line in front of that, means only applying the put the data into the graphical order as well, you will get this kind of structure. Not an issue. Sometimes your data will get in between that, means where in between the line, means it's kind of outlier, you can see some kind of outliers also will get, means the expected values will not get some, in the thousand, in the um, some 10,000 of data you will get in some data outliers, so you can remove, or you can think about the way the previously said, no, the null values affects or not. If suppose if you pass null values into the data set, some 2 to 3, and you are passing that into the algorithm, that time you will not get any problem. Why? Because null values are okay, not an issue. But sometimes that affects on your algorithm and sometimes not affect. It depends upon you. You can pass the data with the null value or without null value, right? The best, the question that we are best fit is nothing but it depends upon your data as well. The question is correct, means what is the best fit? Best fit is nothing but best fit your prediction values, means prediction line, right? The way you are passing the test size, the way you are passing the random state, that is the main thing. Okay, on the which factors, if suppose if you are putting a constant, like test size is equals to 0.20, and suppose random state is equals to 20, suppose 20, and zero point 0.2 is there, means 2080, and our random state is equals to suppose 20, and you are going to train that model. But model training is not a last attempt. Your data is most important, no? If suppose your data is completely pre-processed, the data isn't good, then you are going to train that your model. And suppose what will happen, sometimes you can train your data properly, you are able to work with your model, not an issue. But if your outputs is giving wrong, suppose your outputs, if suppose if you are expecting that output should be a 1 and your output is getting a 0, that time what you do? First you check the data, means how, what kind of observations that we have, what kind of data behavior we have. Second, you have an option that what second your option have, that is a training set and testing set you have to change. Yes, even you have to change the test size, random states. These are the things you have to change. If suppose your data is correct, you have to change with this one. Even mostly people, they think about what are the columns that affects. If suppose your insurance column has an age column, or suppose gender columns also. If suppose that is affecting and giving us a wrong answer, then you can remove the gender column, or that age factor columns also there. age columns are also there. If suppose some columns are affecting on your prediction, then you have to remove. Sometimes gender factor is mostly not affecting. Why? Because if suppose your insurance or banking loan transactions or loan concept is based on the gender male female, then definitely you can go for that. But maximum now we have seen the financial transactional that will not, that is not based on the gender base, means not, that is not in generally like male is having this much possibilities, male is having this much permission and female is having this much permission amount is. I don't know. This is on the basis of the schemes and all the process. But if we think about the generally, then these factors will be important, right? Logistic regression. Now just think about it. This is a sigmoid. You can think about logistic regression. This is the same example that formula. You go for the sigmoid, you go for the logistic regression. Doesn't matter. Okay. Now 1 divided by 1 plus Euler Euler's number. This is a constant number. Euler's number is a constant number. The way the pi value is there, E is nothing but, I'm just telling you, E is nothing but. Okay. Euler's number is a constant value. Actually, we have to check about that Euler's number, why they have provided the constant value, but mathematical. Right? Yes, exponential. That is in 2.771 kind of this value we can get it mathematical. But minus square square minus z is nothing but your value, that is your observational values. So you can pass this Euler's number with this function. Check out observation. So m into x plus b, this is a linear regression. All right, and 1 plus Euler's number minus m into x plus b. So this is your linear regression model, right? And you are passing with the observational value. So this is your main point. If suppose your values that comes and passing into the slope equation. I'm not able to see that chat. Okay, why? I think are first. Everyone is visible. That is visible for the everyone. And now the chats are private. Wait. What happened suddenly? I messaged to the team. No problem. Now, see the major point to be discussed here, where it is. The way we worked on the linear regression and the way we are going to work on the logistic regression. Okay, the logistic regression formula and linear regression formula, and we have implemented the logistic regression, not an issue. But the major point to be discussed here, once again, we can go for the implementation, checking for the logistic regression. But the second thing, we are going to work on the side-by-side cross-validation techniques as well. We are going to do this. Today, we have to cover up the logistic regression and cross-validation concepts. And then how can we implement this one? Okay. So if you guys ready for this one, then say me yes into chat.
Hello, is the chat option disabled? I can't see the chat.
Chat option. Just I message to the team. I think the first 10 minutes your chat option is open, but now I change. I think it gets changes. I'll apply the. I just mentioned into team. Don't worry, it will open within 2 minutes. Just I message to the team. One second. I'll share the screen till then. Check it now, please.
It's the same.
Someone message into chat so that I can get it. It's working or not. The message. Yeah, now what working. Yeah, thank you so much. Hi. Yeah, just I'm sharing my screen. Hmm. Now, so guys, what do you think about if suppose if I'm going to implement a logistic regression, we very quickly we can go for implementation of logistics, and then we are going to discuss about E1 with the credit card fraud detection. I will take the example of credit card fraud detection, and I'm just thinking about insurance as well. So I'm just getting some different data set from Kaggle. So I'll share the link as well. Right. What is the name actually? Today only I just saw that data set. Wait, I will share that data set. What is the name? Insurance data set on Kaggle. Sorry, my spelling is mistake maybe. Okay, yeah. Can I share the link, or if you have? It is taking too much time to explain. You got the link? Can you go for the download? It would be good if you go for the download. See, into the data set, is it visible? No, screen? Yes. Let's go for the implementation. Can we? Let's check out if it is working or not. Okay, means directly connection with the Kaggle where data set. Can we go for that? Can I tell you how to connect your direct data set without any downloading? So first, it will be good for you, no? So no need to download every time. You can get with the API as well, maybe if it is working in the mine slot also. So you will get on some new things to learn here. All right. This is Kaggle dataset link, insurance dataset, and it suppose if I pass with this one, import open datasets as a OD, import open data open datasets as a OD. Okay, this is a library, so you can get it from the Kaggle. Okay, execution. Okay, open datasets. Is it visible? Yes. So I just copy and pasted into that. Just check out. Let me know if you're getting everything or not, because I'm just working on the connecting with Kaggle. So it will be helpful to you whenever we are thinking about Kaggle data set and you want to go for directly connection. You just copy and paste it that link to the your Jupyter notebook and start the work instead of every time downloading the data set and all. Right? Yes or no? Just give me a send the URL in chat. Sir, I shared actually. Open was, wait, I'll check what I have written there. Also, even I don't have that open. OPEM data sets. Yeah, that's correct. OPEM data sets. That's correct actually. Yeah, I have this one. I have to update into. I just yes. Any function to show all available data sets. Available data sets I have to check, sir, because directly I'm connecting this one. In the Kaggle, you will get in directly, but here we'll get in home. Import data set is but link not working. No, no, actually still this link is in wrong. No. Wait. Yeah, now it is working. So I'll just comment here and I'll pass command because when I give you this connect Kaggle to Jupyter notebook directly. Okay. So that purpose, no, there we have they have given one. Wait, I'll show you that link. I'll pass into the chat. This is a link that given by that is now getting problem here to check load this one because the HTTP Kaggle data set directly that I'll go later. I'll tell you the complete tutorial about this one. Better to getting problem in that wasting time, right? I'll do with first this one, and when I get whole concept in front of about loading, because I installed this one, but it is getting little confused. What is that data set? Sage and insurance. Data is in 26, not on big data that we have here. The first thing that we have to do that is an insurance means brought insurance means eligible or not means 22 years of person is eligible for the insurance or not kind of things. So 47 is eligible. This is possible, true, and this is false. Okay, maximum data we have here, and we are going to pass this data. Analytical with the sir, Francis sir, I have checked that analytical with that, but it's not working in my side. They have given the Kaggle content means link, but I don't know why this is not getting problem into the connectivity. Let's see. Okay, so we'll implement this one. I will tell you the whole process first. This one. So now the data. What is the next step that we have to do? What is the next step after loading? Is it creating the x-axis and y-axis? Means x independent data and dependent variable? Yes or no? Tell me. We can go for the quickly implementation of logistic regression. Okay, and we have to go for that. Clean and slicing. Yeah, cleaning as we have known that we have covered, but slicing is important. But you know, another one thing that we have to do here that I want to show you. You can pass this data into the plotting as well, right? So I'll pass one thing. The first time that I will do here in visualization on the matplotlib, it will be useful to you as well. Okay. Is it visible now? Matplotlib import pyplot as a PLT. It's correct. What happened? PL. Okay. Yeah. So now I just want to pass this data into scatter plot so that we can get it easily. PLT dot scatter. Is it correct? Scatter. What is the next step that we have to pass? Dataset dot age, comma, dataset dot. You can before I slice down, I'm just doing this one. Okay, so do not get confused about it. So I'll pass here marker. You know marker. Marker is equals to, suppose if I pass here star. So star you have to pass into okay marker, and color you can pass blue. See this one. These are the values means we are getting here, right? So insurance, this is completely by probability values are there. So some middle values we don't ever getting here, not an issue. And these are the 20 age person can get or not, 30 age of person he will get or not. This kind of the whole data is implemented here. This one. So age and brought insurance. Yes. Now we'll go for making the x-axis and y-axis. Is it possible that x is equals to data set dot I log into the bracket we are passing comma colon -1. Y is equals to, this is easy, we can get it easily. I log now you are able to do without any problem this one, right? X dot shape 27, y dot shape 27. That's correct. Now from sklearn. What is the library name? Can you tell me? Can you tell me short which library we have to pass for the training, testing, splitting, model selection? Yes, you guys, do you know this library which we have to pass? Yes, you have shared in complete code. That's good. Selection, import, what train underscore test underscore split. Okay. Now x train comma x test sorry, test comma y train comma y test into the bracket. Just test every time. Just I forget this one. Yes. Split x comma y comma test size is equals to 0.2 comma random state is equals to 2 or okay one I will pass. Okay. Now which one? What I have to do for the training purpose? What the step that I have to pass here? From learn dot linear what model or regression import logistic regression. Okay, so you have to create here what model is equals to what logistic logistic stick. Okay, elastic regression model we have created and y underscore trade. Okay, then model dot predict into the bracket. You just have to pass what x test. I never pass the any kind of data. So now I will ask to the model about this one as well. See, your x test comma y test. Okay, so the age 58 is allowed for the insurance, 49 allows, but 19 age, 52 age not allowed, and 23 number 45 age is allowed, and 10 age is not allowed. Okay, so this kind of structure we have means we have done the prediction, but we haven't done any prediction means this is an actual prediction. If suppose if I'm passing into the x test, so we have to compare with this one no x previous one. So that purpose I'm going to take one thing. I'll do this one. After prediction, Okay. Okay, before prediction, after prediction. So I'll pass here y and read. So 11001110. So now check out who is into the X test now. I'll pass here X test value as well. So Y test is this one, and X test is this one, and this is Y preview. Edge 58 is allowed 58 and 49. 19 and 52 is not allowed. That is an actual value. But as comparatively, if I go for 19 with the Y preview, this is showing that it's not allowed, and 52 and 45 is allowing. Means model is giving good as comparatively. If I'm thinking about previous one, 52 and 45, okay, and 18 does not having any kind of prediction. Means you can, if suppose if I'm thinking about, if I pass this value directly into the previous, so no in between the predictions. Means Rahul, wait, I'll pass this value into the prediction point in comparatively. I'll pass here. Passing single value. No, actually your value should be into, if suppose that sigmoid concept, if suppose your value is above zero point 0.5, 0.6, and your input functions are on the base of that, means prediction value you are getting kind of 0.5, 0.7, and that time you want to use that logistic regression, that time you will get in answers in the form of 0.5, 0.7. No, you can, you should expect a 1 and 0 only, right? See, I'll pass here 99 and 99 age with the, he says he's allowing. If suppose if I pass 9, he's saying 0. If suppose if I'm passing 19, he's saying it's not all possible to give the insurance. And if I pass 30, it's not possible. Okay, with the 30 also is not possible. With the 32, not possible. 39, possible. Okay, 39 possible. 35 maybe not possible. The, now the think about it, check out the, if suppose 37, I'm saying that not possible, but 38 possible. So now you just compare the values. See what I'm saying. This is the compare the values till the 38. He's giving 0 means not possible, and above 30, above 38, he is trying to give the answer of yes, it is 1. So just think on it. The model threshold that comes till in between 35 to 30, in between that, middle of that. Is it correct? No. Means till the 37 to 38. Yes, only two outputs is allowing here, 0 and 1. You cannot get it uh, 0.5, 0.2, 0.3 something. So now Just think about it. One thing, threshold. Do you know the threshold concept? Threshold means a certain level of limit that after that, if suppose that output is reaches a certain level of limit, that will be executed. How do we represent data to the business users? Business users, how do we? Yeah, actually, another one concept that we have, not only, sir, on the basis of age, you can get it insurance data set. Wait, I will load another one data set of insurance as well. So I think, Francis, sir, you will get it this one example. So you will get a question on this one properly, easily. Means you will get an multiple independent variables. Data set one is equals to pd dot read csv. Same data set I have with the multiple independence values. This is insurance data, but the point is that we haven't get any kind of probabilistic column here, right? So we have to create on this, on the process of this. So if suppose insurance, we can base it on the region, is smoker or not, children or not, expenses or not. And this kind of data set where we have seen in the, where we have seen this concept, the seaborne, implementation of seaborne data. That time we have read smoker, children, and this kind of structure we have implemented visualization purpose. If suppose insurance concept, if I'm going to think about on the basis of business person, means business users, the independent variables are important. Means how many factors you are taking to implement this, means check the insurance policies. Those are in the insurance policies, no? The peoples, they think about what is the age, what is the children, how many children are there, how many this person is a smoker or not. And nowadays, the peoples are, those are in the insurance policies, they have checked everything, means health issues and all. Is it correct? No. And I don't know the BMI means, I think BMI, anyone knows? Body mass index. Yes, yes, body mass index, the measure of related with the body weight and height. BMI. So you know that the people's, means, the range between the BMI concept, that is an, I have checked on the internet. So what is the normal BMI? The ideal BMI of any person, that is an 18.5 to 24.9 range, and children's, no, actually the BMI rate is in 18.5 to 25 age. So I just pass. See, just I have passed for the understanding purpose, BMI, body mass index, right? So what do you think about this? Actually, I didn't get that probabilistic column, maybe, right? I'll check. No, actually, the probabilistic column should be there, but it's okay. I'll check that one for you afterwards. So I think now you got the point of threshold. The threshold point, the Rahul says that say 37.6. Right. If suppose that threshold above the 37 and below the 37, we have to think about it and we have to implement about it as well. And I'm just thinking about one thing here. Wait, I'll show you one thing. Why not I implement the data? Means once again, I just want to pass that data into the prediction world. Can we plot that data so that we can get an difference between that? Is it possible? See, this is a prediction. Okay, prediction that comes. Can we pass the extra in here? Yes, yes, I will tell you. I will inform to my team. Don't worry. See, the same predictions, X test and Y test. Y test is in what? The old prediction is this one, right? Old means actual. Are you getting everyone what I'm doing here? I would like to go for some drawbacks of this one. Okay, drawbacks means the model-based drawback. You got the point, everyone? Till this prediction point, even we have done the visualization as well, right? You guys are there, everyone? Let's go for let's go for one more thing. Let's go for check out the see. Yesterday we have seen uh, the count of categories that present into the Y test and Y test. So which library we have taken that one? Do you know anyone? From collections, import, count. Is it correct? Wait. Counter. So why we are checking this is counter. So how many categories that we can get it with the count as well. Okay. I'll check. Okay, 14 and 13 almost balanced. Almost balanced. Okay, 3 3. Yeah, that's correct. Wait, we'll do in one more thing. Yes, we are discussing about cross validation, but I'm just thinking about counts because this is looks like and completely balanced, so we cannot get it. Uh, we cannot go easily, no, here. So data isn't having low. That's why. Can we think? Can we go for the other data set here, credit card fraud detection, so that we can get a huge amount of difference into the data? Because see here, what happened? Y has an 14 13, Y test has an 3 3, and Y train has an 11 and 10. So this might be a not explanation, means we cannot go deeper into that. So already this is a little bit balanced. But one thing that we have noticed after model slicing, this is going to imbalanced. So data is in 27, so we are not getting too much work here. Wait, we'll go downside here. Now let's check for this one. Print. But I'll show you one. Okay, this is a completely imbalanced, right? So when I go for the data slicing, that time you will get to know that how the imbalancing works. See, so can we use one imbalancing problem here in solving the imbalancing problem? Can anybody tell me which one we can use here? Which one? From IMB LEAR learn dot which over underscore sampling import which one? Random over sampling. Is it correct? Yes or no? Please let me know. This is correct or not. So R1 is equals to this is correct. Can anybody tell me this is correct or not? IMB. Yeah, R1 dot fit underscore resample. So now I want to check counter into the bracket y1 underscore data. Okay, see this is an balanced now. So 0 is 2,84,000 and 1 is 2,80,000, same count we have. So if I pass this balanced data into the model, okay, do you know that this one balanced data into the model, what we are thinking about that? The end part of this one means if I'm passing, when I slice down the data into the models like a train test plate, train test, like a X1 train, Y1 train, X1 test, Y1 test, when I executed this, no, you should get this data completely balanced. But what will happen? Check out y1 underscore data test. So y1 underscore test, who is that? Your train test split concept, no? Is it correct? This one. So when I execute this one, no, check out the sum amount of data is imbalanced. Am I correct? Because we have passed a balanced data and we are getting imbalancing into the model while training to the model. If suppose if I pass this one into the model, my model goes into the maximum numbers of learning with. So if I'm thinking about, see, the difference of this one, near about almost 700 values are imbalanced, almost, right? If I change, some random state, check out the count, check out the count, the difference of this count, 56,942, 56,784. So here also we are getting an imbalance, no? So the solving this problem, that's why we are coming with the cross validation technique, right? In that cross validation technique, we are going to work on which one? k-fold cross validation technique. And if suppose stratify cross technique. Is it correct, guys? Are you getting? So one of that example that leave one out, another one type that there we have the first type that you are working daily means working with the model as well, because leave one out concept that comes under uh, you are removing one test set from the data set. Okay, so what is the test size that you are getting? The test size 20 means that is the meaning of leave one out. You are removing one test case here, test size here, that is on 20%. That comes right. That's why there we have leave one out cross technique. This is a leave one out technique. Leave one out technique is an that continuously you are working, but leave one out has in some limitations, that because you are slicing only 120% of means 20%, 10% of test size, and you are applying on every time. But if I'm thinking about stratify cross validation technique or k-fold cross validation technique, you are going to implement this and dedicatedly on the data set. Means you are creating a folds of this data set, right? Is it correct, guys? Are you getting? Means we are now coming to the point to be discussed. That is an how we are going to balance this. See, the first attempt in the first attempt we have solved the point of data analysis when starting time. In the second, we have solved the point of imbalancing. In the third, we are solving the point of imbalancing in model. Means model learns properly. Now the imbalanced data, we have sliced the 80% of data and passing into it. But now we are doing some differently. Once we covered this cross validation concept, the majorly 99% of training problem will solve in coming days. Because this is the last point that remain to the training to the model. Means this point is remaining only. Means we can believe on the model with this one. That model is giving us truly good values and good answers. Concepts are till we haven't covered, but this point is important. Cross validation, k-fold cross validation, and other words as well. Means stratify cross validation, right? So for the implementation, I will give you one example now, and from tomorrow onwards, k-fold cross validation stratify we are going to implement, and tomorrow only we will go for KNN. Okay, k nearest neighbor, because simultaneously we are coming we are solving the imbalancing problem as well as this cross validation. Then k1 knn, once we covered knn, no, then we go for the some homework based and assignment based work exercise as well, because they every class we cannot go for the new task, no, else you will get an extra data burden on the mind. That's why we go for the assignments and examples as well. Okay. Okay. The logic behind that and PPT, I will create and upload that into uh, on the domain portal. Okay. So k-fold cross validation technique. So I will explain the code here and the concept as well. The concept that is, actually I don't have an PPT here now, but I will show you one thing. The code. Wait, I'll pass the code here. Okay. Screen is visible. See, the code as well as this process I'm going to implement first. First, this is a k-fold cross-validation technique. See, as we know that we can divide a data into training set and testing set. But the drawback of previous one, that is you are sliced down the only one test case and you are applying on the multiple training data model as well. Means if suppose if you want to create a multiple test, uh, if you have sliced the train cases, means 500, 500, 500, like a train cases, and you if you train to the model, afterwards in the previous model what we have done, we only slice down the 20% of data and applied on the original data set. But k-fold cross validation, one thing he is going to do, that is an slice down the whole data set, means pass it down your whole data set into the multiple iterations. It's kind of for loop. For loop, how the for loop it works, means same concept on the multiple times, on the multiple iteration times. Similar kind of that, here we are going to create multiple iterations, but every time, every iteration has a different test cases. Means suppose this is a whole data set is in 1000. See what I'm saying? Your whole data set is in 1000 observation point. The 20%, 200 test cases and 800 is in train cases. 200 and test cases and 800 and train cases. So what kind of process that we implement? See, if suppose I'm just telling you this whole data set, if suppose 1000, okay, okay, so this is x value, that he is containing x as well as y data, right? He is containing x as well as y data. This is x train. See what I'm saying? This is x train and y also. This is x and y also. Means what you are getting here, this is also a x test, x train and y train, and this is also a x test and y test. Means it's the same way the previously you have done. But here you are creating a multiple folds for the multiple iteration purpose. It depends upon you. See what I'm telling to you. A difference is in between how many times you can iterate a same data set. Means how many times you can go for that. So multiple, if suppose if you pass the 5 times, you will get in 5 iterations. If you are passing 10, then case size and 10, then he will iterate 10 times. But every time, means every process, you will get on different test cases and different train cases. The first, if you iterate, test size is in 200 and 800 is in your train cases. Second time, next 200 is in test case, and first one and last one means remaining point that comes into the training case. So every time same process will go for the algorithm. Means here is in your logistic regression sitting here, and you are giving same process to train. First, then second, then third, and then fourth. Every time he is learning differently, and every time he is giving you a accuracy score different. This is for the accuracy score different. This accuracy score different. This accuracy score different. This is also different. This is also different, because in the middle of that, here sitting who is logistic regression, and every logistic regression gives you a different accuracy scores for the every iteration. Different accuracy score for the every iteration. So every one will goes into throughout the logistic regression, give us a different accuracy score. So just understand the point is that if suppose if I go for the implementation of this one, but definitely will get a problem here. Can you think about it? Is it possible that we can get it here problem? What do you think? Can we get an imbalancing in the iteration as well, in the folds as well, if we divide our data? Means if we pass our data in the 5 iterations, is it possible we can get an imbalancing in between that? What do you think? Hello? Because just think about it. If I pass here 1000, if I pass here 1000, see, 200 you are doing for the, you are passing in 20%, you are passing into the test cases, and remaining 800 passing into the train cases. Here also imbalancing problem will come. Balancing will not come, because you are passing balancing data. But when I slice down the test size, every time your test cases changes, and here also a imbalancing problem will come. Is it correct? No. Because balancing problem, your imbalancing problem also comes into the model training time. But that problem will not solve 100%. We are teaching simultaneous multiple subsets to the model to avoid this one. Model can learn all the things. Model can learn all the things. So if model can learn all the things in proper manner, you have to do iterations. And but the iteration purpose, what we are getting here also, we are getting imbalancing. Means sometimes your 0 and 1s are there, 200. Sometimes 180, sorry, 120 will come zeros and 80 will come ones. Are you getting this point? This is also problem, no? If suppose this is getting this one in the second attempt, sometimes here hundreds of zeros and hundreds of ones will come. Is it correct what I'm telling? Next time, what is the probability that model will give the properly? Here 80 will come zeros and 120 will come ones. Here also imbalancing, here also imbalancing. Are you getting? Is it correct what I'm trying to say? Because test cases every time changes, no? Are you getting my point? Every time your test cases are changes, every time processor changes. The cross validation concept gives you a multiple iterational points that you can work it. Your model can learn every and each and every data, so that model can gives you a strong prediction point. Because in the first attempt we are getting in the previous our own model we are getting some problems, imbalancing problems. Model can learn only on the basis of your single data set, single iteration, but cross validation technique gives you a multiple iterations to work on it. But in the multiple iterations also model having some problems. But in this cross validation first concept k-fold model is capable to give a proper answer. But some disadvantage is also there, that he can get a little bit imbalancing concept into the every iteration of your category data. So solving this problem, there is a second type, that is an stratify k-fold cross validation technique. Your stratify cross validation technique try to solve that imbalancing between the k-folds, means imbalancing between the folds. He can try to balance that categorical data properly. Is it correct what I'm trying to say? Everyone, are you getting this point? Yes. Yeah, little bit complicated. This is a first point, no, first attempt our towards the cross validation. Little bit complicated, but problem is an imbalancing. What I'm saying, your problem is an imbalancing. No, see, I think today you go for the logistic regression implementation and imbalancing implementation. Try to go for the whole process. When tomorrow I will come, no, that time I will show you a major issues towards the cross validation. Means when we go for the implementing cross validation, and you will get to know the whole working. Because I will not implement today, because you will get in complications in between the logistic regression, imbalancing, and this one. Today will not go for the three problems, three modules. Only we have covered 2 points till now. One logistic implementation, logistic logic, and this imbalancing also we have solved previously, and this one cross validation. But when we come up with the tomorrow, we'll implement the stratify k-fold cross validation and k-fold cross validation. Okay. Until tomorrow, go for the example, go for the explanation of implementation of this one, because once we covered the cross validation concept, no no complicated points are remaining. Directly we go for the implementation of other algorithms as well, because now we are having some important ways that implementing the projects and all those are things. When will be the talking about the Power BI and Tableau? I have to check about, sir. Definitely, I will think about. I will discuss about the team as well, but I will discuss Power BI and Tableau as well. You will get to know that. Sure. AI. Once we covered this point, we'll go for the AI, because artificial neural network is after completion of machine learning. I think next till the next week we will cover up almost machine learning points. Uh, Next week maybe. Yeah. Yes. So let's go for the tomorrow session implementation. I will share this file today, today's file and yesterday's file. Yesterday also we have covered um, interesting points, and we'll come up with the tomorrow session. See you on tomorrow session. Thank you so much for joining this session. Thank you. See you. Take care.